Excellent. So continuing on talking about how to name alkanes with one substituent, let's now at least review how to identify or at least draw on paper skeletal versus condensed structures if we are given the name for an alkane with one substituent. Understand that all this naming that we're going to be doing in organic chemistry, we typically call it Iupac naming because the Institute of Applied Chemistry, okay, is what determined all of the naming that you guys have done so far, okay? So the naming that you guys did for inorganic compounds, meaning ionic compounds versus molecular compounds, and the naming that we're doing now, it comes from the Iupac Society, or the Iupac system, I should say. So, so whenever we're talking about Iupac naming is the naming that we have been doing so far. So let's look at the first molecule we have, 1-chloropropane. When we are given a name and then we have to draw the molecule, I always suggest students starting from drawing the longest carbon chain and then adding the substituents, then adding the hydrogens for a condensed formula. But for skeletal, you will see that is a little bit different process because we don't have to write in the carbons or the hydrogens. So let's look at the first one, 1-chloropropane. So if I'm trying to draw the carbon, the parent chain, the number of carbons there, and since I have propane, how many carbons do I have? Let's put it in the chat. If I have propane, how many carbons in the longest carbon chain, in the parent chain? Great job, you guys. 3, propane, 3 carbons. So I will write in my condensed structure, my 3 carbon atoms. Now, see how it says 1-chloro? Because I'm drawing it, I can put that chloro on either side to symbolize carbon 1. I can say, hey, this is carbon 1. There may be a student out there that's trying to be a little bit more adventurous, and it's like, oh, I'm going to do this as carbon 1. Whichever way, okay? You can make that chlorine pointing, straight into linear. You can make it point up. The important thing is that you select what is going to be carbon 1, and then you stick the chlorine to it. So let's say that I'm going to stick it here. That's my chloro. Next, I'm going to add the hydrogens, okay? So that first carbon is going to get 2 hydrogens. Why? Because it's already attached to 2 bonds, one to the chlorine, one to the next carbon. The middle carbon also gets 2 hydrogens because it's attached to 2 bonds. Remember that the goal here is that every carbon atom has 8 electrons, okay? In the case of an alkane, 4 single bonds. How many hydrogens does the last carbon get in this condensed structure? Excellent. See, you guys are getting the hang of it. 3. So this is my condensed structure for 1-chloropropane. When it comes to the skeletal structure, okay, first I draw in my parent chain. 1 carbon, 2 carbons, 3 carbons. Remember that in the skeletal structure, we are illustrating those 109-degree angles that each of those carbon atoms have because they're tetrahedral. And then this is my parent chain, that's my propane. And then because each of the angles is 109 degrees, here I draw my chlorine. And that is the skeletal structure for 1-chloropropane. Let's move on to the second one. 2-iodopentane. How many carbons in the parent chain, you guys? Let's put it in the chat. Pentane. How many carbons? Excellent work. 5. 1, 2, 3, 4, 5. If it's 2-iodo, at carbon 2, I'm going to put an iodine, and now I'm going to fill in the hydrogens. Starting from left to right, how many hydrogens does the first carbon get? Great. How many hydrogens does the carbon with the iodo group get? What about the next two carbons? How many hydrogens do they get? Excellent, this is a CH2. What about the last carbon? When we draw the skeletal, we say this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. And then this is my carbon 2, I put the iodine. Next one, 4-isopropyl decane. How many carbons in the longest carbon chain? Excellent work. Great job, you guys. You're getting the hang of organic chemistry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons in a row. Then on carbon 4, I put my isopropyl group, which is a CH that is bonded on either side to CH3. I include the hydrogens. This is a CH3, CH2, CH2, CH, CH2, 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 CH3. Okay? When I do my skeletal, carbon 1 up, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8, carbon 9, carbon 10. For those of you that may have to take organic chemistry later in your life, understand that those dots are not written. So it honestly, understand that traditional organic chemists will not appreciate having those dots. For Chemistry 104, because I know that you guys study organic chemistry for a limited time, I don't have a problem with those dots, okay? So understand that if you have other professors, they may be like, those dots do not exist. I know, but then we're just learning organic chemistry. So for me, it's okay. For you guys, no problem in this class. So here, since this is carbon 1, carbon 2, 3, 4, 5, 6, 7, 8, 9, 10. On carbon 4, how we illustrate an isopropyl is that here's a dot, there's a line, there's a line. So isopropyls always look like a Y. Okay? Any questions? Given the name, it's just that it looks like a Y. I don't know, when we draw the skeletal of it, it looks like a Y. So at least for my students in Chemistry 104, because again, you guys spend, you know, a few weeks doing organic chemistry. That's why I give you guys those hints so you remember. But the most important thing whenever we're dealing with this is just know how to draw them, know how to identify them, but the main thing is to identify the longest continuous chain. Any questions going from name to structure on alkanes with one substituent? Since there are no questions, let's now move on to what about if I have an alkane, but I have two substituents or more that are the same, okay? So you guys will see that throughout our conversations of learning how to name organic compounds, the #1 rule is always the same. Find the longest continuous chain of carbon atoms. That's going to be like the rule that, is gonna sink in. She gives me a molecule. Let me find the longest continuous chain of carbon atoms. Okay, that's rule number one. Then you can see that rule number two is very similar to what we did when we had only one substituent. We're going to number the carbon atoms starting from the end that is nearest to a substituent. Okay, now when we have multiple substituents that are the same, we're going to give in front of the name of the substituent the prefix di, tri, tetra. Again, di is for 2, tri is for 3, tetra is for 4, and then if you have 5, it's penta, 6, hexa, so on and so forth. We're going to give that in front of the name of that substituent. The numbers for the locations of those substituents, we have to separate them by a comma, and that is always given before the name of the substituent. And remember that the separation between numbers and words is also a hyphen. So let's do the condensed structure that we have above. How many carbons do we have in the longest continuous carbon chain on the condensed structure? Great job. We have 5. These 5. So that means that we have 2 substituents that are the same. This one and this one, okay? So the last word in my naming is going to be the name of that longest continuous chain, and we're dealing with an alkane. So what is the word that I'm going to use for this parent chain of 5 carbons? Thank you, Gia. Pentane. 5 carbons, pentane. Now, I'm going to number, look at step 2, number the carbons starting from the end that is nearest a substituent. Who is going to get the numbers? The parent chain, okay? So this parent chain, I'm going to do 1, 2, 3, 4, 5 carbon atoms, right? That's why we know we have a pentane. Now, what is the name of that substituent that I circled in red? A CH3. What do we call a CH3? See, you guys are getting the hang of it. Methyl. Now I have 2 methyls. So I'm not going to put methyls with an S. I'm going to use a prefix to see the number of that methyl group. Great job. Di. For some reason, a common mistake that I see when it comes to this, I don't know where students put bi. Bi is a prefix that we use in chemistry, but it's usually for inorganic compounds. We don't use it in like organic compounds. We don't have a prefix of bi to signify 2. We use di with D as in dog, okay? So dimethyl. And then, because I'm putting the location of those methyl groups, I'm going to separate that using a hyphen, and then I have to give the location of the methyl groups. So even like in this example, the methyl groups are sitting on the same carbon. You need to give their location. So you have to say, I have a methyl on carbon 2. I have another methyl on carbon 2. So that 2, 2 represents the location of my methyl groups in my parent chain of a pentane. Okay? Because a common mistake that sometimes I see is that students assume like, oh, 2 because there's 2 methyls and then 2 because of their location. No. The 2 and the 2 represent the location for each methyl. Because if those methyls were in 2 and 3, then you say 2, 3 dimethylpentane. Okay? Let's look at the bottom example. Again, we have 2 substituents that are the same. What is the longest carbon chain in my skeletal structure in the bottom? Great. 1, 2, 3, 4, 5, 6, 7, 8. So because there's 8 carbons in my longest carbon chain, what is the name of my parent chain? Great job, octane. Now, let's determine which way am I going to number it, left or right to left. We have to number this from the end that is nearest of substituent. Great job, Marisol. When it comes to this, you can see that if I number it left to right, 1, 2, 3, 4, 5, 6, 7, 8. Or if I do it in the other direction, 1, 2, 3, 4, 5, 6, 7, 8. In either direction, they're going to be in position 4 and 5. So you can pick any of the two, just because they will have the same numbering. If they were about to have different numbering, remember, start from the end that is nearest a substituent. So I'm just going to erase the red one. That'll be easier. So what are the names of my branches here? I'm going to circle them. What is the name of this branch and this branch? Again, we have 2 of the same. Great job. You guys are already adjusting your eyes to know how ethyl groups look in skeletal formula. So these are ethyl groups. Okay. We have 2 of them. So we're going to do diethyl. And we're going to give their location. One is on carbon 4, one is on carbon 5. Let's practice naming alkanes with 2 or more of the same substituent. Let's look at the first one. Four carbons in the longest carbon chain. So I know that my last word is going to be butane. Numbering, I'm going to do 1, 2, 3, 4, because I have to start numbering from the end that is nearest a substituent. My substituents that are the same are methyl groups. I have 2 of them. So I'm going to put the word di, and then I'm going to give the location, 2, 2. Okay, so that is 2, 2 dimethylbutane. What about the next one? Longest carbon chain. How many carbons? Awesome. 7. So if we have 7, what is the name of that parent chain? That's the last word in our name. Great job. What is the name of my substituents? If they're Cl. And since we have 2 of them, dichloro. Okay, now I give their location. 1, 2, 3, 4, 5, 6, 7. Great job. Thank you, Jenna. 2, 4 dichloroheptane. Okay, I'm going to give you guys, I'm going to be here observing the work on the chat. Let's name the following condensed structure. What will be the name of this one? Let's start with the parent. Great, Gia. This is heptane. What will be the prefix and name for the substituent? Great job, you guys. Yes, trimethyl. Great job. Excellent for the students that are participating in the chat. This is trimethyl. Let me number this, starting from the end. 1, 2, 3, 4, 5, 6, 7. Great job. Remember, if you have 3, you need to give me 3 locations. So 3, 3, 5. So the prefix will tell me how many numbers I need. So if it's, as you can see, di, 2 numbers, di, 2 numbers, try, I need 3 locations. Let's move on to this skeletal. What's the name of the parent chain? You guys are getting the hang of it. So proud. 1, 2, 3, 4, 5, 6. Now that I have my parent chain, let's look at those substituents that we have. What is the prefix and name for the substituents that I have here? It's a methyl, great. How many of them we have? Again, when we have a substituent that is just a line, at the end there's a CH3. There's 4, so what's the prefix for 4? We learned that prefix before when we were dealing with covalent compounds. No. Great, thank you guys. So this is tetramethyl hexane. And then I need the numberings. Let me number this. If I have tetra, I need 4 numbers. What are the numbers? Exactly, 2, 3, 3, 4. You guys got this. Let's move to the next one, the next skeletal. Name of the parent chain. Awesome. 1, 2, 3, 4, 5. What is the name of the prefix plus substituent? Great, fluoro. And how many of them? Great, trifluoro. And give me the 3 locations for my trifluoros. Where are they at? Last one. Let's see, somebody in the chat, fully name this alkane with multiple of the same substituent. Let me see, who got this? Put it in the chat. Ooh, I like that name. 1, 2, 3, 4, 5, 6, 7, 8. That's where the octane comes from. Thank you, Francisco and Marisol. Thank you, April. Great job. Octane. 1, 2, 3, 4, 5, 6, 7, 8. Try ethyl. And then the location is 3, 4, 6. Question. Naming alkanes with multiple of the same substituents. We haven't done propyls yet. We have only done isopropyls. We're going to see the propyls soon. Oh, propyls can pop up in any of these. But we have only seen isopropyl so far. Marisol, I didn't understand your question. Repeat what part? So I'm just checking if anybody has questions of like alkanes with one substituent or alkanes with multiple of the same substituent, because now we're about to dive into the third class of alkanes. No, wait, you will see them soon. It's just that in these molecules, I haven't added propyls, only isopropyl. Great, if there are no questions, then let's go to the next class, okay? And you will see that in the in-class worksheet, I didn't, categorize them as alkanes with one substituent, alkanes with two substituents, alkanes with, like this, multiple substituents that are different, okay? So this is a new class because I want you guys to practice enough that when you are given a molecule, you will be looking at it and say, oh, this is an alkane with one substituent. This is an alkane with multiple substituents. This is why you guys need to practice, practice, practice. In Canvas, I actually put a website that I found online where it allows you to practice naming of any organic functional group. You can practice drawing, you can practice naming. So make sure that if you want to solidify naming this week, you go and practice as much as you can with the problems in the in-class worksheet, but also that resource. Because next week, we already have an exam on all of this. So let's deal with the next class, which is alkanes, but now we have different substituents, okay? So rule number one, we know rule number one. We're going to find the longest carbon chain of atoms. But here, because we're still dealing with alkanes, we're going to write that name. Rule number two, still the same rule that we've been doing throughout. Number the carbon atoms from the end that is nearest to a substituent. Then, when we have different substituents, we need to give the location, but we need to be guided to write those substituents in alphabetical order, okay? And remember, whenever we have names and words, we're going to separate them by a hyphen. So let's do the following examples, okay? When we look at the first molecule, the condensed molecule, how many carbon atoms do we have in the parent chain? How many carbons in the longest carbon chain? Great. 6 carbons. So we know that the last word in this molecule is going to be hexane. Okay? Now, we have 3 different substituents. We need to number this from the end that is nearest a substituent. So are we doing left to right or right to left? I see that people are saying left to right, right to left. Let's do the numbering. We go 1, 2, 3, 4, 5, 6. In the other direction, 1, 2, 3, 4, 5, 6. If I list my substituents, I want you guys, I'm going to teach you guys a trick to select which way does it make sense. In one direction, I have 2 fluoro, 3 ethyl, 5 methyl. Put a 1 in the chat if it makes sense where I got these from. The 2 fluoro, 3 ethyl, 5 methyl. Again, in the red arrangement, this is how I will be numbering it. In the blue one, I will be saying 2 on the methyl, 4 on the ethyl, 5 on the fluoro. Okay. Notice that the numbers are different and it does matter. Okay. On which direction I pick, either right or either red or blue. Okay. So in the numbering that I gave on the red, okay, I see that my substituents are on 2, 3, and 5. But in the blue assignment of numbering, I see that my substituents are in 5, 4, and 2. How do I determine which numbering is correctly? Let me show you a trick. Add these values. The one that gives you the overall, that's going to be the numbering. 2 plus 3 plus 5, that's 10. 5 plus 4 plus 2, that's 11. So that tells me that this is not the correct numbering. Remember, this trick is going to be for when you have multiple of the same. So if you don't know which direction you want, write them in both directions. And then if you add them, the one that gives you the lowest value, that's going to be the right numbering. Do I need to repeat that again? Yes or no? Again, this is for when you have multiple substituents. Okay, let me say it one more time. When you have multiple substituents that are different in your molecule, you need to number them starting from the end that is nearest a substituent. In either direction, your first substituent is going to be technically on number 2, right? It's just that in the red direction, your number 2 is the fluorine, but then in that direction, left to right, that means that your ethyl group is on carbon number 3, your methyl is on carbon number 5. If you do the blue direction, you will say, oh, this is 1. My methyl is on number 2. My ethyl is on number 4. My fluoro group is on number 5. So how do I know who wins? Well, when you look at both numbering system, if you add the locations, the one that gives you the lowest number, okay, that's how you determine numbering. That's the first thing. Are we okay with numbering? Put a 1 in the chat if you see why I picked the red numbering versus the blue numbering. This is where it gets tricky when we have multiple substituents. That's why we're practicing today.
Professor, so you said whenever it's the smaller amount, when you're doing multiple substituents, it's always going to be that direction.
In this case, it is because when you go in either direction, your first substituent is on number 2. So you're trying to see, okay, so if number 2 is my first numbering, let me look at all of the numbers. And then, just like you said, Alexa, the smallest overall addition, and this is just a trick. Instead of, because usually when you go to textbooks or other resources, they tell you, you have to pick the lowest numbered. And then students are like, but what does that mean? This is just a trick. Add those values, the lowest overall.
But it only applies for multiple substituents, correct?
Yes, for multiple substituents.
Okay, thank you.
Great question, Gia. There's going to be occasions until they equal the same number. And when that happens, then you have to select the numbers that give the substituent that comes alphabetically first. So if they equal the same, then you pick the number that gives the substituent that comes alphabetically first, you give that numbering. But I think there is a problem like that in the worksheet, but I don't think I have it in lecture. So again, going back to this, because there was a question in the chat, okay, how do I now write my substituents? I need to do them in alphabetical order. That's the third rule. So now that I know their location, as a prefix of my hexane, I need to write these substituents in alphabetical order. So who comes first? Which substituent? Great, the 3-ethyl. Because remember that the 3 will come with the ethyl, because that's the location of the ethyl. And then what comes next? Great, the fluoro. And lastly, great. Let me just erase this hexane. (5-methyl hexane). Okay. So this goes to the question that we had here. The question in the chat is like, if you had to write out the Iupac, how would you know to write it left or right? Remember that the numbering in step 2 is establishing that I'm going to start numbering from the end that is nearest a substituent. Okay, so for example, let's do the skeletal structure that we have here. How many carbons in the longest carbon chain? I think you guys are pros at that already. How many carbons in the longest carbon chain? Great. 1, 2, 3, 4, 5, and 6. I'll just write it here. So what is the last word in this compound? What is the last word? The name of that parent chain. Great, that hexane. Now, when it comes, again, I have multiple substituents. Some are the same and some are different, but I need to start from the end that is nearest a substituent. So let's just do this again. I can go 1, 2, 3, 4, 5, 6. Or I can go 1, 2, 3, 4, 5, and 6. In the red numbering, okay, I have 2, 5 difluoro, and I have 4 bromo. In the blue numbering, I have 2, 5 difluoro, but I have 3 bromo. Based on the rules that I already gave you guys. I see, great job. People are catching up to it. As you can see, the arrangement in red makes me overall to have, okay, an addition of 11. It's not, I do not want you guys to think, oh, if it's 11, it's not correct. No, that's not what I'm saying. When I'm comparing these two numberings, the red one is a larger value overall compared to the blue one. So in this case, this numbering is not correct. So the blue numbering, but again, this is very special. This is only for when I have multiple substituents. So since the blue arrangement, okay, comes first, or is the correct numbering, how do I write my substituents? Who comes first? Who comes first alphabetically? Bromo or fluoro? The bromo, right? 3 bromo. 2, 5 difluorohexane. One more thing that we're going to see later, specifically in the practice. The prefix di does not get alphabetized. When you're comparing an alphabetization, you're saying fluoro versus bromo. Okay, we're gonna see examples of that because that's the other mistake that students say. Let's say that it would have been dibromo, or no, that's not a good example because di is, anyways, we'll see it in the practice problems. Let's do some practice before I let you guys go. Let's find the longest carbon chain. You guys are pros at this. Longest carbon chain. There you go. Great job, Gia. Great eye for it. Yep, this is the propyl. You see it here. Awesome. Okay. So this is my octane. When I'm numbering this, I have to do it from the end that is nearest a substituent. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So here on carbon 3, we have a methyl. On carbon 5, we have a propyl. So who comes first, methyl or propyl? Remember, the numbers just tells you the location for them. Great, the methyl. So this is 3 methyl, 5 propyl, and then octane. Let me just write it closer. And this is all one word. Three methyl, 1 propyl, octane. Let's try to do as as many of these as we can before I let you guys go. Oh, look at this beauty. How many? Oh, the dash is always to separate numbers and letters. Always. The dash is always, so the hyphen or dash is always, the comma is to separate multiple numbers. So when we have multiple of the same, we use comma to separate the numbers between, so if you guys see at the example, see how we have difluoro? The 2 locations of the fluoros are separated by a comma. But then numbers and words, always a hyphen or a dash. Ooh, look at this beauty. How many? It's not a decade. Count again. It's not 7. There you go. Great job, Francisco. It is 9. That's my longest carbon chain, 9. Now, this brings up the question that Gia had in a few moments ago. When I have these 9, first of all, what's going to be the name of the parent chain when we have an alkane of 9 carbons? Great job, Marisol, Francisco. Yeah, you guys got this. No name. So Gia had this question a few moments ago, and let's go over it. If I do the numbering, I say 1, 2, 3, 4, 5, 6, 7, 8, 9, versus 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the red arrangement, okay, I have 4 ethyl, 6 methyl, but in the blue one, I have 4-methyl versus 6-ethyl. Okay, so if you use the trick that I showed you guys a few moments ago, and this is what GS question was like, what if they both add to the same number? No problem. Only in these instances, then alphabetical order wins. Okay, only in these instances. So let me just write it here in the notes. When the numbering is equal in value, then alphabetical order determines the correct order. Again, we are dealing specifically with alkanes that have multiple substituents. So in alphabetical order, ethyl will be placed before methyl. So that's why the correct order is going to be the red one. It's only in this instances. Sometimes I find that students make their own rules, but you said alphabetical order. No, I said alphabetical order when we do the numbering, they give you the same number for your substituents. That's the only time that alphabetical order wins. Other than that, we always go by numbering the parent chain closest to the first substituent. That is always the rule. Alphabetical order is just to distinguish these two. Okay, so that means that for this compound, we have 4-ethyl, 6-methyl, no name. Questions on this example? This is a very particular example. This is not going to be every time. Let's do at least one more practice problem before I let you guys go. How many carbons in the longest carbon chain here? Great job. See, you guys are already pros at this. Eight. Okay, those are my 8. So the substituent that is closest to the end is that methyl group. So when I number this, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. So what is the name of my parent chain, you guys? Name of my parent chain. Great, octane. I have 3 substituents. Which one comes first alphabetically? Not fluoro. Great job. The ethyl group. And I give the location of my ethyl group. At carbon 5, I have my ethyl group. What comes next? Great, the fluoro, awesome. At carbon 4, I have my fluoro group. And lastly, what's the last one? Great, at carbon 2, I have my methyl. There was a question in the chat earlier. Whenever I have numbers and words, I separate them by a dash. See that we don't have commas? Because remember, commas is only to separate the numbers of the locations when I have multiple of the same substituent. We have 2 minutes. We can do this one. This doesn't have like a long parent chain. How many carbons in the longest parent chain here? Awesome. You guys are on a roll. Great job. Those are my 6 carbons. So what is the last word here? If it's 6 carbons. Great. Hexane. Now, I'm going to number this right to left or left to right. Mm-hmm. 1, 2, 3, 4, 5, 6. Okay. So when it comes to this, in alphabetical order, three fluoro, 2, 4 dimethyl. Don't think I'm crazy or I don't know my alphabet in English. The reason why fluoro comes first, I mentioned it in the previous slide. Let me just highlight it. Di does not get alphabetized. Okay, so when we are comparing here, what I'm alphabetizing, I'm comparing the M in methyl to the F in fluoro. So the 3 fluoro will come first before the dimethyl because the di doesn't count in the alphabetization. So out of the 3 different types of alkanes, the one that has the most rules is going to be when we have multiple substituents that are different. Okay. Any questions on alkane naming? Great. That is all for today.